So, welcome back to this lecture. Now we will discuss chiral resolving agent. Today's topic is chiral resolving agent. So, what are the chiral resolving agents? So, these reagents, or they are solvent. In fact, they are used to distinguish the enantiomers. Okay, in the NMR spectrum. So, we use in this technique, we use the a particular solvent which is having the chiral compound. So therefore, they are called as the chiral resolving solvent. These solvents can be used to dissolve the mixture or racemic mixture of the compounds. So now see how to do this, how to achieve it, how to start, how to begin. Let us consider that a group, there is a group which is attached to a chiral carbon. And normally we know when there is a chiral carbon, so at that carbon the groups are called as enantiomeric groups, and they have a same chemical shape, right? If group is converted into diastereomeric or diastereotopic group, so we can expect that NMR signal will be different from its enantiomer or from its another isomer. So to make such a group or convert into diastereotopic group, so the chiral compound needs to be treated with a very pure chiral optically active compounds, and such compounds are called as a chiral resolving agents. So few resolving agents are here mentioned: S mandelic acid, S O acetyl mandelic acid, and R bienol, S bienol, and also Mosher scent. These are the chiral resolving agents or chiral solvents which can be used to resolve the NMR spectrum. Now, let us start with this experiment. Have a chemical. What are the chemical required? An apparatus. We need a mixture of a sample which contain a chiral carbon, racemic mixture, and we need our chiral resolving agents, mandelic acid and NMRT. So what is NMRT? See, like you can see, it's very beautiful, made up of glass, okay, particular glass. And what you do when our mixture, racemic mixture, we have taken here alpha-phenylethyl amine, which contain 50% R, 50% S, or we don't know the percentage, suppose. We don't have idea of percentage, okay? Don't think it is always 50-50. It can be 40, 55, 60, 40, many things, many combinations of possibilities are there. So now to that, you take O-acetyl mandelic acid in a NMR tube, which contain CDCl3 already. Shake it properly and let us go for the uh, observation. So see, this is have a reaction. See, this reaction is the phenylethylamine, which is a basic in nature due to the presence of lone pair here nitrogen. When you react this with the phenylenediamine, sorry, no, when you, this mandelic acid, O-acetyl mandelic acid, there is a transfer of proton from this to this NH3. This become ionic, and after becoming ionic, that is called as salt. So our target is to identify the CH3 group. So now in this group, in this salt, CH3 have its special position, and another salt will form, which is of having the CH3 group with a different position or different orientation. So this S means this will retain as it is. Here also S, here also S. What about this carbon? Here it is R, here it is S. So now we have a RS nomenclature, or we can say RS configuration in this salt, and here we have a SS configuration in this salt. So from these two salts, which are now called as the diastereomers, in these two salts, which are diastereomers, these two methyl are not same, these two phenyl are not same, these two CH are not same, these two NH3 are not same. So like this. This pH are not same, CH are not same, OAC are not same. CH, this is the meaning of is the meaning of diastereomer. Now these two methyl, if you focus these two methyl or two phenyl or two, they will not give us same signal. They have give a different signal. See, we have done this. We have reacted this with S-madelic acid. You got the two salts, diastereomic salts, or they are called diastereomers. Okay, right. SR and SS. Fine. Now, now these two methyl groups we are considering, you can consider phenyl also, no problem. They are attached to two different carbons because this, when these carbons, the two compounds become diastereomers, means every atom, eight position become also diastereomers. So this carbon is also not same, are also not same. Those pH is different from air from for this, right? Now see, so now once you got these two salts, they have a different chemical shift value, and because they are diastereomers, therefore they will give a different chemical shift values for two methyls. And though the distance will be less between them, but they will appear at two different chemical shift values. Fine. So here it is mentioned about two methyl groups. They will appear at approximately maybe less difference 1.1 and 1.2 ppm, and each methyl group, due to the presence of its neighboring one proton, is splits as a doublet each proton. So this is what we can say. Okay, and after giving integration to these peaks, there are two peaks available. You can find out the maximum percentage of peaks, or based on this maximum percentage of integration, you can find out the amount of sample which was present in this week, which was present amount of the amount of the, or percentage of the S or R in enantiomer. If this is a small, means it's having the very uh, what we say less small integration, 295 nanometer millimeter, and it is a very big 740 millimeter. So this is the more value of integration, less value of integration. So this one of them, one which is having the more value of integration, that will be the more in percentage, or more in amount, or more in enantiomeric excess, and while this will be less or very less in the enantiomeric excess. Enantiomer, okay. So like this, we can find out the uh, percentage of the enantiomers in a given mixture, racemic mixture, by using the chiral resolving agents such as acetyl madelic acid in this case. Okay. So this is what about the concept of using of chiral resolving agents in separation of the peaks and identifying by integration. Okay, this is what about the this chiral resolving agents. And on base, what is next point? Application of chiral resolving agent into find out the how much amount is of S and how much amount of R is present. Which one is more in amount? This can be calculated by applying different concept. So we will discuss this in the next lecture. Okay.